our colleagues in the U.S. This is the 15th annual Indonesia-U.S. Bmkg Noaa Ocean Climate Observations, Analysis, and Maritime Applications Partnership Workshop. We're just waiting for a few colleagues to join us, and we'll be starting in just 2 or 3 minutes, please. Thank you. Terima kasih.
Thank you, Mas Ni. Halo, masuk hari ini.
Ma You can start, Sydney. I'm sorry, a little technical meeting, technical error.
Selamat pagi, dear colleagues in Indonesia, and good evening to our dear colleagues in the United States. Welcome to day 2 of the Indonesia-US Bmkg Noaa 15th annual partnership on ocean climate observations, analysis, and maritime applications. I'm Sydney Thurston from NOAA's Global Ocean Monitoring Observing Program, and I have the honor of beginning today's session, day 2. I'd like to take just a minute to outline what we're going to be doing today. I will start with a brief summary of the presentations from our VIPs yesterday during the opening ceremony. And then I will invite my co-chairs, Bu Nelly and Pa Dodo, to please make some comments on yesterday's workshop and today. Then I would like to review the agenda for today. And then I'd like to please take a few minutes to do some questions and answers from yesterday. We heard a lot of information, a lot of material, and you've probably been thinking about it in the last 24 hours, what you heard, and you may have some questions. So if you do, I'd like you to please think about it now, and in just a few minutes, we'll have a question and answer period from yesterday. And then we will go into breakout rooms, and we have a process in place for that, so we'll explain that in just a few minutes. Basically, we'll go into a climate science group and an ocean science group, where we will actually receive to hear the presentations. So if that is acceptable with everybody, I would like to take just a couple minutes now to just to provide an overview, a brief summary on what we heard from our distinguished panelists yesterday during the opening ceremony. I was very pleased with the comments, and I think you will be also. There is a YouTube video. I think Pa Arif has circulated that YouTube video, and it's a recording of the entire day 1, including the VIP opening ceremony, the keynote by Dr. Mike McFadden, and the keynote by Professor Arnold Gordon, and the other presentations we received. I really recommend that you take a look at that day 1 video just to review all the rich material that was presented, and realize we have a similarly rich agenda tonight too. So we were really blessed to receive some opening comments yesterday from the U.S. Embassy Charge d'Affaires, Heather Villavera, and she mentioned the importance of our 15-year Indonesia-NOAA partnership. She said that Ambassador Joseph Donovan, who made opening remarks last year when we were together in Bogor, recognized our partnership as one of the U.S. Indonesia's longest running S&T partnerships. She noted that Bmkg is one of the most reliable and productive partners that the U.S. Embassy in Jakarta works with. And she said the work that Bmkg does is significantly important, not only to Indonesia, not only to the region, Southeast Asia, but also to the world. And she was very complimentary of Bmkg as she was of the partnership with Noaa. And then after U.S. Charge d'Affaires made her opening comments, we heard from Rear Admiral Tim Gallaudet, who's the Deputy Administrator in Noaa. And Tim actually logged on early, and he really enjoyed listening to Bmkg colleagues, just chatting, friendly chat in Bahasa, of course. And he got the sense that Bmkg, they really like working with each other. And Tim and I talked today after the meeting, and I confirmed that. I said, Tim, I've been over in Indonesia for almost 2 decades now, and it's true, Tim. It really is true. Bmkg colleagues, they really have a lot of fun working together. Tim remembered his, when he was in the Navy, he was an admiral in the Navy, and he was in the Navy for 32 years. He remembers fondly his shore leave in Batam, Indonesia, where he really learned about the Indonesian culture. He was there for several days, and that was his first exposure and experience with the friendly hospitality of Indonesia. Admiral Gallaudet went on to say that the partnership we've been building for 15 years between Indonesia and Noaa is a national priority. He said that this long-term partnership between Indonesia and Noaa for ocean and climate and weather is a national priority, and he's committed to making building up our partnership even more. He really wants to work more closely with Bmkg. And as two of the largest democracies in the Indo-Pacific region, he said that this was a very important partnership for stability in the region. And then, of course, Bu Rita made excellent comments. She spent a lot of time at the beginning talking about the science and the observations and how climate change will impact Indonesia, Jakarta, the Indonesian archipelago, Southeast Asia. And she went into that in quite some depth, I thought. And then she spent a lot of time, and I was very pleased to hear this, the importance of the next generation. Bu Rita is very keen on empowering the next generation because she quoted I think it was Indonesia's first president several decades ago, 7 decades ago, who said, the youth will shake the world. And the way she said that, it seemed like she was very passionate about that. So I was pleased to hear from Bu Rita. And then Tim Gallaudet also concluded by saying, we have several priorities, U.S. and Indonesia, that closely align. And one that he is very passionate about is the blue economy. And he wants us to be working more closely together because we share interest in the blue economy. So I was very pleased. I reviewed their opening speeches several times because they had a lot of nuances and fine points that I wanted to capture. But those are sort of the highlights, I think. And I think we should all feel very satisfied and very gratified that we're doing really important work, not only for our own countries, but for the region and for the world. So with that, I'll stop my summary. That's just my personal view on the opening ceremony. And I'd like to invite Bu Nelly and invite Pa Dodo, my co-chairs, if they'd like to share their perspective. Terima kasih.
Okay. Thank you very much, Sydney. Thank you for the summary. So I don't have a specific comments, but I can say that we had a very wonderful day one yesterday. Thanks to you, Sid, for all the arrangement, and of course I want to thank the speakers, the moderator, the rapporteur, and all the participants, and of course all BMKG's colleagues behind the scene. I do hope that we will ready right now to enjoy our day two workshop. Thank you.
Got comment for me. Uh, Thank you, Pak Sid, for the review of the opening or day one. And I think even it is virtual, the opening is virtual, but it's not, same look like the real meeting. We have 100 participants, and all the opening key person that very important person that open our event. The only maybe the constant of this event is just the difference of time. So I'm sorry for the inconvenience time for colleagues from the US. And when the Indonesian young scientist session in the late, maybe for you is already late evening, or maybe you already left. It's, we had some young scientists presenting about their work, their results of research, and this is quite good as addressed by Ibu Rita. Yeah, so we encourage the young scientists, and now also the participants. I think all the young scientists from all mainly Indonesian nationally of the Bmkg, but also from outside of Bmkg. I seen in the report of the organizing committee that some from universities, participants come from several universities as well as from another institution. Hope this next remaining day of our workshop still interest for all, as is so many expert sharing expert from the US, from Noaa, that we are very that is very important now for us. I think that's my short comment from this about this one day and day one, and we continue. Thank you, Pak Sid.
Terima kasih, Pak Dodo. Terima kasih, Bu Nelly. Thank you both for your fine leadership in organizing this important workshop, and thank you for your opening comments today. I would like to just recognize that you mentioned the time difference, and it's really our honor. It's our honor to sort of work at night from the U.S. We have maybe a dozen or so, maybe 20 U.S. colleagues, but certainly the majority of the participants are in Indonesia. We want you to be fresh and during your working hours. It's across the entire archipelago. We realize that. That's across all your meteorological stations, across the archipelago. And I understand tonight now it's open to the public, this workshop, and also the Bmkg College of Meteorology. Your students are joining us today. So it's really our honor to be able to deliver scientific content and material that your Bmkg colleagues and Indonesian colleagues will benefit from. So we're good with the time, and we're fine. Thank you very much, Pak Dodo. So at this point, I'd like to briefly review today's plan, and basically we're going to go into 2 breakout rooms. This will be the first day where we have breakouts. We'll go into the climate science group, and we'll also go into the ocean science group. And those in the ocean science group can just sit tight, calmly. We will use this same link. Okay, but if you're going to go into the climate science group, Reef will be sharing another link with you in just a few minutes. So let's begin with Carl Schreck. Will be with the North Carolina Institute for Climate Studies, and he'll be basically leading the climate science group today, day 2, on equatorial atmospheric waves. Carl will be talking about introduction of equatorial atmospheric waves. How do you monitor the waves? There'll be a question and answer session, and then he'll go into some hands-on training using interactive mapping and tools. So that will be today's climate science group. The ocean science group, we have just an outstanding lineup to talk about progress on the years of the maritime continent. Dr. Chidong Zhang from NOAA's Pacific Marine Environmental Laboratory will be leading that session. Again, Professor Arnold Gordon will be leading the MINTI discussion, measurements and modeling of the Indonesian through flow. And then after Arnold's finished, we'll have a break, just a short 5-minute break. And then we're really happy and pleased to have Janet Sprinthal with us from Scripps, talking about the equatorial line observation, or ELO. And then Asmi Napitu from Colombia and Indonesia, KKP. She'll be joining us talking about the Madden-Julian Oscillation and its relationship to the Indonesian seas. So we have 4 outstanding presentations and discussion on each of those during the ocean science group. So that's the agenda for today. And as promised, I'd like to take now maybe 5 or so minutes to just open it up and go around the room. If anybody has any questions, you can raise your hand, please, and open your mic and your camera. Or if you don't feel like going public, you can simply write a question in the chat room.
Yeah.
But this is our time now. We had a lot of information yesterday, and we want to make sure everybody's clear, moving forward. We don't want any uncertainties at this point in time. So if you have any questions about today's agenda or yesterday's material, now would be the time to ask your question, please. Let me check the chat box. Let's see, if you could please, let's see. I see some Bahasa, which I can't read, unfortunately. Again, I thank you all for joining in English. If someone, Padodo or Parif, if you see a question in Bahasa, if you could please read that, that'd be great.
There is no question, but Miss Rima will continue for a while.
Okay.
Well, I'll go ahead.
Okay, thank you, Pak Arif. Ladies and gentlemen, let me inform you that Mr. Adi Ripaldi will be the chairman of the Climate Science Group, and Mr. Erwin Makmur will be the chairman of Ocean Science Group. Ladies and gentlemen, we remind you again, for Climate Science Group, are requested to move the room to the link that will be shared in the chat room. So please check your chat room now. And for Ocean Science Group, are requested to still stay in this room. We will have a 10 minutes break for parallel class preparation. I do hope our workshop today will be very useful for all of us. I would like to apologize if there is any inconvenience. Thank you very much for your kind attention. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih. We did have a question we
maybe inform also for Carl Strike to move the. Pak Sini, actually we designed another room for the climate science, so including for Carl.
Carl, could you please follow a new link that do you see the link in the chat room? There is
yes. So
yeah, this one. So could you follow that link?
we did have a question.
Yes,
Could
we
we
did.
could
Yes,
we
please.
ask? Can we have a question and answer session before we break into the
Yes.
two breakout rooms? We did have some questions. I see one here from Noah, colleague, so I can handle that question from Ken Connell. Ken is the Rama project manager at NOAA's Pacific Marine Environmental Laboratory. He says this question is regarded to the report on the 2019 Inna Prima Rama cruise that Wilmar presented. And Ken thanks Wilmar for the summary. I really enjoyed the presentation and the video. Ken Connell says in the evaluation summary, he noted that you listed two recommendations. One was permit in case of extreme weather, particularly at 15 north. And then the second point was intensifying transfer of knowledge. Could you please elaborate or provide additional clarification on the first recommendation regarding extreme weather at 15 north? Who would like to answer that question, please?
Do we have Wilmar here?
I think yeah, he's here.
Wilmar, can you answer that one?
Wilmar monitor.
Yeah, he's
He
in
is
the
here.
list.
He joined.
If someone could please unmute Wilmar, that would be helpful.
He already unmute actually. Arif, can you call it?
Maybe there's some technical error from his side.
Can you call Arif?
Yes. Should we wait? Okay. Maybe if it takes too long, maybe we can continue.
Yeah, we'll come back if Wilmar. Let's take some more questions, and Ken Connell. We'll come back to that when Wilmar is able to unmute. Are there any Bahasa questions, please?
There is none. There is no more question, I think.
Some text in Bahasa is about the information on the classroom. Pak Sini.
Okay, yeah. Let's move
room.
on. But I would like Wilmar to answer Ken Connell offline, please. If we could take that action item. If Wilmar could just send an email to Ken Connell.
Yes.
Okay. I see no other questions. Bunelli and Padodo, is it okay with you if we go into our breakout rooms now?
Yeah.
Okay. Then if you're in the ocean science, we'll just stay here. And Carl Schreck.
I would, yeah, I think we are ready to go to the breakout, Pak.
Terima kasih, Pak.
Yeah,
We'll see you later.
For Pak Wilmar, later on you can answer Ken, yeah.
Great. Terima kasih. Have a good climate. I'll be in ocean session, Pa. So I'll see you later.
Yeah. See you later.
Pak Dodo will be on
Yeah,
the climate
I'm
session.
in the climate room.
Okay,
Pak Imam,
so I will pass.
Yes, please.
At this point, I'd like to invite Pa Irwin. I understand Pa Irwin will be chairing the Ocean Science Group, so the floor is yours, Dr. Irwin.
Hello, Sydney.
Ah,
Okay, thank you very much. See you again.
good to see you
By
again,
the
too.
way, I had a message from Dr. Chidong. He had some problem with his audio, so maybe now he left the group. So maybe
Can you hear me?
Oh yeah, Chidong.
Hey,
Yes, Tino.
hey, Tidong. Yes,
Hi.
we hear you.
Finally.
Yeah.
You get the background also.
Okay. Okay, thank you, Sydney. So, Bu Nelly, can we start now?
I think we can. I don't know. I think we will stay a couple minutes. Yeah.
Yes.
To make sure that the participants are already here.
Yes, yeah, we still need wait a little bit. I'm sorry, I will speak in bahasa. Untuk peserta yang baru datang, jika dari Klimat ada link untuk ke kelas Klimat. Terima kasih. Cek.
We welcome to the class climatology. We will be discuss today with the expert of the equatorial waves. Has coming Dr. Carl Sek. Good evening, Dr. Carl. Could you please
there we go. Thank you. Can you hear me?
Yeah, we can hear.
Yes, that's good. Good evening for Dr. Carl and good morning for everyone in Indonesia. Welcome to climate class. This is the second day for our workshop, and today in climatology class we will be talking about the atmosphere equatorial wave. So we will be happy because we has coming Dr. Karsek. Dr. Karsek is investigate tropical weather and its impact around the globe, and he's also particularly interested in identifying and predicting in the median Julian oscillation that really influence the climate variability in maritime continent like Indonesia. And he also engaged with partners in private industry to explore how this system can improve long-range forecasts of the weather risk over the United States, including the hurricane, extreme precipitation, and extreme temperature. And he also partnered with the forecaster at Noaa, CPC, and National Hurricane Center to improve the extended the forecast of tropical cyclone genesis and tropical rainfall. And Dr. Carl also is passionate in assessing and reducing uncertainty in historical tropical cyclone, district, including through the cyclone and citizen science project. But today we will not talk about the tropical cyclone or hurricane. We will be talking about the equatorial atmosphere wave. We have here about the Rossby wave. We have here about the Kelvin and also the median Julian oscillation. We never or we didn't clearly understand about that. So this good opportunity for us to learn with the expert, with the Dr. Karlstek. And we should know that his publication, the new one publication that he has write is about the impact of the MGO, Kelvin and Equatorial Rossby wave on the diurnal cycle of the maritime continent. As we know that on June, July, we have the anomaly rainfall in Indonesia, even the dry season for us, but we have the winter condition in the dry season. So what happened in this, maybe Dr. Karl will be talking a lot about that. And thank you for Dr. Karl. So this is your time.
All right, thank you very much. This is really an honor to be able to speak with you guys today, and hope that I'm able to answer some questions and share some insights into equatorial waves and how they can impact the weather in your region. So let me share.
Do you want to share by yourself or by us?
Probably if I can drive, that's probably easier.
Okay.
Yeah. Can you share?
Yes.
Yeah. It's not ready. Yeah, that's good.
Okay.
Great.
Okay. So kind of the main points I'm going to talk about today, go through some of the main wave types that have already been mentioned here, talk a little briefly about easterly waves, mixed Rossby gravity waves, Kelvin waves, equatorial Rossby waves, and the MJO. Those last three are kind of the real key ones. And I'll be talking a little bit about how the MJO and these various equatorial waves form this like hierarchy of convection where they build upon one another and have very similar structures, both in terms of their clouds and their convection. And I'll talk a little bit about the main way that we track these waves. It's primarily through filtering for the wave lengths and the periods associated with them. And I'll also give a little bit of an overview of how we track the MJO using the real-time multivariate MJO index, or the RMM. So easterly waves are, one of the more commonly studied types of waves. It's not a true wave. It doesn't have a dynamical solution, but it's essentially this open wave embedded within the easterlies. And they tend to be very important for tropical cyclogenesis in really all basins. They probably tend to curve northward in your region, so probably not as much of an impact there as in other parts of the world. And sometimes we talk about them as tropical depression type disturbances, since they kind of share some characteristics with tropical cyclones, even though they're still just open waves, so not a true tropical depression. So mixed Rossby gravity waves are the first of the true equatorial waves that I'll talk about. And these are waves with alternating cyclones and anticyclones, or really clockwise and counterclockwise circulations that are centered directly on the equator. And part of what's fascinating about these and really all the equatorial waves is these were first really theorized back in the 1960s using very simple shallow water linear equations. And for a long time, it wasn't really thought to be of any practical significance necessarily outside of perhaps the stratosphere. But in the last few decades, we've gotten a better understanding that they really couple with the convection. And so for a lot of these equatorial waves, similar to including the mixed Rossby gravity waves, the enhanced convection tends to be where there's enhanced convergence at low levels associated with the theoretical wave solution and or enhanced divergence at the upper levels. So as I said, the mixed cross-speed gravity or MRG waves, they have these these circulations centered right on the equator, and the poleward flow is where the enhanced convection is going to occur. So the northern hemisphere will get convection within the southerlies. The southern hemisphere will get convection within the northerlies at low levels. And part of what's interesting is that in your region, it's really fascinating how these waves turn northward and transition into more of a tropical depression type system or an easterly wave, and can eventually spawn tropical cyclones and typhoons. The other thing that's really unique about mixed cross-speed gravity waves is that they have a very strong group velocity. And so that means that you'll see one wave, the group velocity, the waves themselves move westward like an easterly wave, but their group velocity actually moves eastward. So you'll see one wave dissipate, and then very quickly you'll find a new wave forming just to its east. And you'll see these patterns of these very tight wave packets with mixed cross-speed gravity waves. Kelvin waves are, I think, arguably the most important of the equatorial waves, and also another one that's, until very recently was probably underappreciated. Their theoretical structure is very simple, just alternating westerlies and easterlies on the equator, with the westerlies happening actually within a high pressure system and the easterlies happening within a low. And essentially where those converge, you'll get a rising motion, and that convergence leads to increased pressures, which propagates the system eastward. And so they're never really in balance, but they're always moving this interesting couplet of westerlies and easterlies moving eastward fairly rapidly. And they're actually synoptic scale, essentially waves that you could, with a little bit of training and experience, you can actually identify these on a weather map without filtering, but certainly the filtering helps quite a bit. And they move pretty rapidly eastward, 10 to 20 meters per second. And again, you get enhanced convection where the winds converge at low levels. And what the other interesting thing, we'll talk a little bit more about the MJO later, but the Kelvin waves really exist on a kind of continuum with the MJO, where they share a lot of common features and common structures. Both of them move eastward, just at varying speeds and wavelengths. And so you'll often see these Kelvin waves grow larger and become an MJO, and you'll also find some MJO events that will kind of fade away into a Kelvin wave. Equatorial Rossby waves are another one of those shallow water solutions, and these have pairs of cyclones or anticyclones straddling the equator, so you'll get a low in the northern hemisphere and another low to its south. And in these cases, the enhanced convection is again in the poleward flow, so the northerlies in the southern hemisphere, the southerlies in the northern hemisphere. And these also can be very important for tropical cyclogenesis, where you'll find the tropical cyclones tending to form at kind of that intersection between the enhanced convection and the enhanced cyclonic vorticity with the low level, with these twin cyclones. And you can actually get twin tropical cyclone events out of these. And the other thing that's really interesting with these is they can interact fairly strongly with the MJO. So you'll see a convective envelope of the MJO moving eastward, and then perhaps you'll see a suppressed phase of the equatorial Rossby wave intersect with it. And you can really, it can really hide or mask that enhanced convection with the equatorial Rossby, or with the MJO, so that the equatorial Rossby wave suppressed phase can actually counteract the MJO's enhanced phase. And at least in my experience, that seems to be particularly common in the maritime continent region. So now moving on to the MJO, the Madden-Julian oscillation. So this was, at least in the Western literature, was first discovered back in 1971 by Madden and Julian out in NCAR. And more recently, we've discovered that there are actually some papers a few years earlier out of the Chinese literature that were talking about the same event. But what Madden and Julian were doing is they had kind of a fairly new supercomputer, and this was the 1970s, for very early computing days. And so they put in radiosonde data from Canton Island, essentially in the Central Pacific. And they were just kind of playing around with it, trying to see what kind of spectral signals they could find in the data. And so they were calculating these power spectra, like the one shown here, showing the amount of power at different periods or frequencies. And like pretty much all atmospheric variables or geophysical variables, it's a very red background, meaning that there's a lot more power at the lower wavelengths or lower frequencies and periods. And that's because there's a lot of autocorrelation, that the weather today is very strongly correlated with the weather tomorrow and the next day. And so this kind of stationary signals tend to dominate. But even with that, you can see a pretty clear peak around this like 30 to 60 day period. And as they went further into this, they discovered that it was this planetary scale feature that moves eastward at about 5 meters per second, and was also pretty strongly coupled with convection. So I'm sure, I imagine you may be familiar already with the kind of broad composite of the MJO, but essentially it tends to develop over the Indian Ocean and gradually move eastward across Indonesia, and then ultimately go into the Western Pacific, and during the summer it even makes it over to the Eastern Pacific. And its convective phase is much stronger in the Eastern Hemisphere than the Western Hemisphere, so it tends to take quite a bit longer going through the Eastern Hemisphere than the Western Hemisphere. So I'll talk a little bit more about some of the ways that we track those later, but first I just wanted to talk briefly about some of the theory that we've been using to learn about equatorial waves and the MJO. And I think one of the most fascinating things is this idea of building blocks, or this kind of similarity we see between scales. So this is a cartoon from Straub and Colodis in 2003. It's looking at a Kelvin wave, but there are very similar diagrams for the MJO, for everything really from an individual MCS all the way up to the MJO, so from mesoscale all the way to global scale. And so if you think of this picture moving from left to right, essentially you start off with an area of clear skies and subsidence and general cooling in the mid-levels associated with that clear subsidence. And then you gradually start to warm the surface and get cumulus congestus, or shallow convection, that starts to help moisten the low levels. And eventually you get deep convection that goes through the full column, and it's followed by stratiform which is still warming up above, but creates cooling at the lower levels. And then as the stratiform dies off, you'll have subsidence again that will again cool the entire column. And all the while, you've got this in, up, and out circulation associated with it. And like I said, this is a remarkably consistent feature among all scales in the tropics, and really fascinating how robust this kind of structure seems to be. Another way of looking at this is moist static energy, which I won't pretend to be an expert on. Chidong, who's probably in the other session, I think, is one of the better experts on this. But moist static energy, it's kind of a way of looking at. It's related to equivalent potential temperature, and it's a way of looking at the amount of humidity, moisture, and heat energy within the column. And this has been proven particularly important for trying to understand why the MJO moves eastward the way that it does. And a lot of we're still very much trying to figure out what the MJO is. It doesn't have a theoretical structure or a theoretical backbone the way that the Kelvin waves and the equatorial Rossby waves do. But the current consensus seems to be that it's this type of moisture mode, where it's this kind of balance between the ascending vertical advection of those moist energy from the surface and the precipitating it out, and also a lot of impacts from horizontal advection of the moisture. So obviously, there's a lot of moisture over the maritime continent region. The Indian Ocean is a lot drier, especially in the Western Indian Ocean. And so as the low-level low-level easterlies become enhanced over the Indian Ocean, it transports some of that moisture westward into the Indian Ocean, which helps fire off the convection there. And then gradually that kind of coupled enhanced moisture and enhanced convection gradually moves eastward, with the convection always kind of chasing after that enhanced moist static energy. So now I'll transition to an area that I'm more comfortable speaking about, and this is how we monitor equatorial waves. And I'll be talking more about the specifics of my website after the break a little bit later. But for now, just kind of an overview. And I apologize if any of this is too rudimentary or too well known to you. But hopefully you can learn something along the way as well. So one of the main tools that we use for tracking both the MJO and especially equatorial waves is outgoing long wave radiation, or OLR. And really, this is the same as the infrared brightness temperature that you may see from geostationary satellites. It's essentially it's strongly correlated. They're strongly related to each other. But the OLR tends to be measured off of polar orbiting satellites. And so that provides a global picture of essentially the cloud cover. And so OLR is very useful in the tropics because, if you've got a clear day, OLR is essentially responding to the temperature of the highest thing it can see. So if you have a clear day, the satellite's seeing all the way to the surface, like in the Middle East and the Sahara here. And you're seeing a very hot surface, so you're going to have very high values of OLR. Whereas in the ITCZ and monsoon regions, where there's a lot of cloud cover, the satellite is only seeing the top of the cloud, so OLR is much lower. And so it's kind of a way of approximating the intensity of the convection. Rainfall is obviously an even better measure of the convection, but it's harder to observe and estimate from satellites. OLR is a much more direct measurement. So that's part of why we like to use it. And specifically, we tend to look at it in terms of Hofmullers. And, like, this is something that isn't always, it takes a little while to get used to thinking about in terms of Hofmullers. So here is a product that the National Hurricane Center puts out on the left. And essentially what this is just a series of Did I get muted? Okay. So essentially this is a series of satellite images from each day and stacked one on top of each other. And stacking them up like that helps you track individual cloud clusters or easterly waves a lot more easily. So here's a easterly wave that turned into a tropical storm in the Atlantic recently. But it's still a little bit tricky to look at individual pictures like that. So it's easier to just average the OLR or any other variable over a latitude band so that we can flatten this down. And that's what the Hofmullers are. So these are diagrams where time is usually going downwards, but in some other websites, you'll see time going upward on the y-axis. And then the x-axis is longitude. And so that's a way to easily pick out where different modes are going. So if something is going down to the right, then it's moving eastward, like the MJO or a Kelvin wave. And if it's going down to the left, it's an equatorial Rossby wave, or something else that's moving westward. So kind of the next step of that is, we'll take the anomalies from a daily climatology to make the picture in the middle. And so that's a way of getting rid of areas that are just always going to be more convective than other areas and kind of level the playing field a bit. And then ultimately what we do is Fourier filtering. So going from the center to the right, the shading is really basically the same. It's just that now we're adding contours on there to identify the filtered modes for some of these key modes. And I'll talk a little bit more in a moment about exactly how we do that. So first, kind of how we discovered that these modes were so important was, again, by doing spectral analysis. So in this case, this is a two-dimensional spectrum, so in both space and in time. So frequency or period is on the y-axis from a 2-day wave all the way up to 48 days and beyond as you go farther down. And the x-axis is wave number, which is related to wavelength. So if you have a wave number 1 pattern, it's either, there's only positive or negative around, as you go around the equator, where wave number 2, you'll have 2 positives and 2 negatives. And so to convert that into wavelength, the circumference of the Earth at the equator is about 40,000 kilometers. So if you divide 40,000 by wave number, you get the wavelength. So a wave number 10 feature, for example, would be 40,000 divided by 10, so about 4,000 kilometer wavelength. And what was really fascinating when George Claudis and Matt Wheeler and others started looking at these spectral diagrams about 20 years ago, once they removed kind of that red background that's associated with the very stationary autocorrelated signals, they started to see that the enhanced peaks in spectral power really lined up with these black lines, which are just the theoretical dispersion curves from the very simple linear shallow water models for Kelvin waves, equatorial Rossby waves, and the MJO. And so this was kind of their first hint that these waves weren't just an academic problem in shallow water, that they were actually important for convection as well. The other thing I want to point out here is that a lot of times the MJO has been treated as very distinct from Kelvin waves, and part of the justification for that is, the MJO is by far probably the largest peak on this diagram. If I had the diurnal cycle on here, that would certainly rival it. But there is a little bit of a break in the spectral power between the MJO and the Kelvin waves. And so for a long time, that break was kind of used as a justification for separating the two. But as we've looked more closely at kind of the details of how this analysis is done, it's becoming clearer that that break is somewhat arbitrary, and that maybe there is this continuum of disturbances going from the MJO to Kelvin waves. One of my professors at University of Albany, Paul Roundy, has done a lot of the pioneering work on looking at these similarities. But so essentially we use this spectrum partly to identify the importance of the waves, but also to identify the filters that we're going to use. And there's a lot of variations on how different researchers will identify the waves. But essentially, the ones that I use are, for the Kelvin wave, it's bounded by the shallow water dispersion curves, but then also periods longer than 2.5 days and shorter than 30 days. And the other thing I should point out is that in this spectral diagram, the positive wave numbers are eastward moving signals, the negative ones are westward moving. So equatorial Rossby waves, it's kind of a filter somewhere between 10 and 50 days. And some people bound it by the dispersion curves, others don't. MJO tends to either be something like a 30 to 60 or 30 to 90 day filter, and wave numbers like 1 to 9 tend to be a typical selections, or 1 to 4 depending on how narrow the filter is. And then the other filter that I use on my website is just a low pass filter, because I think a lot of times in this framework, folks underestimate the importance of the low frequency background, that kind of stationary signal. And so I do a 120-day low pass filter to pick up on anything that's just kind of like an ENSO or IOD type signal that's just going to stay there for a while. So again, looking at this on a Hoffmuller, and I apologize, my website is actually down today. It's been down for a couple of days. I think it'll be back tomorrow, but so this is about a week old. But even so, you can see on here a few things. So the shading on here are the anomalies from climatology associated with the OLR. And then the contours are the various filtered wave modes. So the blue contours are Kelvin waves moving rapidly eastward and fairly narrow in scale. The black contours are the MJO, which is also moving eastward, but a bit slower and much larger in scale. And then the red contours are equatorial Rossby waves that move gradually westward. And then the pink or magenta is this stationary low frequency signal. So, for several months now, convection's been very enhanced over the Indian Ocean. Seems, reasonable to expect that to continue for some time. And, one of the things that's fascinating when I look at these diagrams is a lot of times, especially at this time of year, when the MJO goes eastward, you'll see just this string of tropical cyclone formations going along with it. So it's really fascinating to watch how tightly coupled they are. But you'll also see that sometimes with Kelvin waves and some of the other waves as well. So one of the other interesting things with this filtering is that filters have an issue when you get to the edge of a data set. Basically the filter has to be kind of set to 0 at the edge of the data set. And that can be problematic for real-time monitoring and forecasting. And so Wheeler and Weichmann back in 2001 had a solution that was fairly simple, where they just padded the observations with climatology, or zero anomalies going into the future. And this was surprisingly powerful because it allowed the filter to extrapolate the signals of the wave. So, you know, if you have an MJO today at the date line, you can bet that probably tomorrow it's going to be a little bit farther east, because we know the MJO just tends to move eastward. And so, to a first order, forecasting these waves should be pretty easy, and the filter can extrapolate it if you just pad with zeros. One of the things I realized about 10 years ago was that surely the CFS and some of these other numerical models are going to be more skillful than climatology. So why not pad with those instead of just this climatology? So that's what I do on my website, is instead of padding with climatology in the future, I'm padding with a 45-day forecast from the CFS and then climatology thereafter. And so that allows the model to help extrapolate some of these signals a bit farther. You can see that pretty clearly with that Kelvin wave, for example, here. Where the model, even if it doesn't have a great Kelvin wave, is probably going to be able to extrapolate it a little bit farther than what you can do with just the filter alone. So now I'm going to transition to talking about the MJO and the RMM index, and giving you just kind of a quick overview of how to interpret that. And the MJO is interesting because, most atmospheric oscillations or teleconnections that we look at are just a single time series. It's either positive or negative. And the IOD are examples of that, where it's just a single value and you can watch it go up and down. The problem is that's really good for a stationary oscillation like ENSO, but it's not so good for something that propagates. And the MJO goes all the way around the globe. And so a single index would kind of miss that propagation. It's not just on or off, it's also kind of moving as well. So Matt Wheeler and Harry Hendon in 2004 developed the real-time multivariate MJO index, or the RMM. And essentially what they did was they took the first two EOFs, empirical orthogonal functions, for a combination of OLR, U850, and U200. Each of those averaged from 15 south to 15 north. So at least theoretically, this is a combination of OLR for getting the convective signal, but also the winds to get the circulation signal as well. So you get that full in, up, and out circulation that we were talking about earlier. The problem is that OLR is a much noisier variable than the winds, and so this tends to be very strongly driven by the winds, and we'll talk a little bit more about that later. But nonetheless, this has really become the industry standard for tracking the MJO. And one of the things that I thought was just really neat about when looking at this is that the longitude where EOF1 has kind of the strongest U850 and U200 It just happens to be pretty much right at Canton Island, where Madden and Julian back in 1971 were first looking at where they first discovered the MJO. And so in a way, they were really looking at the right place at the right time to discover this signal. So here's an example of the RMM index. Hopefully the animation is coming across on Zoom. And essentially what you can see is that the MJO tends to go counterclockwise around the RMM index. So again, this is a two-dimensional index, so it's not just positive or negative, it's giving you both phase and amplitude. So the farther it is from the center, the stronger the signal is. So for example, in the red, in phase 1, it gets to a fairly large amplitude during October, whereas in phases 2 and 3, it kind of skirts back within this circle. So if it's inside that circle in the middle, we tend to call it inactive, although certainly a case like this where it just goes briefly through the circle, I wouldn't have said that, you know, the MJO wasn't there anymore. It's just kind of weakening a little bit relative to where it had been before. The other thing, so part of what makes this so powerful of an index is that it's really easy to apply both to observations, but also forecasts, and even climate models have used this to see how well the models are able to replicate the MJO. One of the kind of drawbacks of it is that it's a very simple index. So it just subtracts out a retrospective 120-day running mean to remove the signals like ENSO that are more stationary. It doesn't try to do anything to remove higher frequency signals. So sometimes you'll see it kind of double back on itself or suddenly speed up, and those tend to be associated with equatorial waves. So if there's a period like in November here where it suddenly moved pretty quickly around the circle, odds are that was associated with a Kelvin wave. Whereas a period like in December where it kind of circles back on itself, that's probably associated with an equatorial Rossby wave pulling that signal back to the west, you know, going in the opposite direction of what the MJO wants it to do. Another way I really like to look at the RMM index is with this kind of Hofmüller diagram that I created. Now, this isn't real data or a composite. This is just taking those EOFs from the Wheeler-Hendon slide and kind of projecting them around and seeing what would be the amplitude in each of the phases. So phases 8 through 1, and then 1, 2, 3, 4 again. And so essentially what this is showing you is what is the RMM index sensitive to. And so it's really sensitive to OLR signals around 90 degrees east. And if you go back here, you can see at 90 degrees east, there's a pretty strong peak in the OLR in that region. And then it's kind of to a secondary amount sensitive to OLR near, say, 150 degrees east. But it really doesn't care what's happening to the OLR in the Western Hemisphere. It just doesn't matter. Kind of the opposite with the zonal winds, it's primarily associated with the UA50 over from 60 east to 60 west, more or less. So kind of over the Indian Ocean through the Pacific. The upper levels, it's really opposite, where it's much more sensitive to the winds at around 60 west. So sometimes you'll find that if a trough from the extratropics is coming down and just enhancing the upper level westerlies right at 120 west, sometimes that will project strongly onto the RMM index, even though there's not necessarily a full MJO event going on. So I find that looking at this and comparing it to the observed Hofmullers is a way to kind of figure out what the index is thinking and try to get a feel for what's going on at a given time. So again, just to kind of wrap up this part of the presentation, so we talked today about some of the various equatorial wave types. Again, probably the most important for forecasting, I think, are the Kelvin waves, the equatorial Rossby waves, and the MJO. I'm very focused on subseasonal to seasonal forecasting, and so that's where those play the biggest role. On shorter time scales, easterly waves become a lot more important, and mixed Rossby gravity waves. And I didn't talk about them today, but eastward and westward inertial gravity waves are also very important in your region. And, these are these 2-day waves that really come into play. And then, we talked a little bit about some of the theory behind the MJO and how the MJO and equatorial waves are kind of building blocks that share these common features, and that we mostly track the waves using Fourier filtering that can pick out the main wavelengths and periods associated with the different waves. And we can do that for the MJO as well, but it's more frequently tracked using this RMM index. So that was the end of my first presentation. I believe we were going to have some time for questions before and a break before we transition.
Okay, thank you very much, Dr. Sharp. It's really, really good information for us. Really, really interesting, and many information that you explained in this first presentation. So we open for the class discussion for everyone or participant. There are some questions, Dr. Sharp, Dr. Srek. I will wait for you. So the first question is coming from Dr. Amsari Setiawan. He asked about how can we identify which atmosphere wave that can be considered as the main cause of certain extreme weather or climate event in certain region. The second question is how to determine the contribution of certain atmospheric wave to rainfall anomaly over the specific area. Number 3, how can we know when certain atmosphere wave occur in our region? For example, Borneo Island. For example, from 90 until now. And can we get the net CDF data used from the NCICS.org for a replot of a specific region? I think this is 4 questions from Dr. Setiawan. So please, Dr. Sri.
Yeah, so these are very good questions. And how to identify which waves are associated with a specific extreme event, it is a very challenging problem, and one that I'm very interested in, and I would love to collaborate with you guys on trying to figure out solutions. Typically, I do it in a statistical sense where I look at the number of those extreme events that happen once a particular wave reaches a certain threshold, and try to see which of the filtered anomalies are the strongest at a given time. But in terms of an individual extreme event, it's much more of an art than a science of just looking at which of the signals seem to be the strongest and kind of picking them out that way. Very similar to how you, for the second question of how you determine the relative contribution of the different waves. It's very challenging because the filter captures kind of the main signal of the wave. It's really good for tracking the waves, but it's not so good for getting the amplitude of the wave. a lot of times a wave will have a nonlinear impact that's larger than what shows up in the linear filters. And so that can make it difficult to break apart which of the, what the relative contribution is of each of those.
Number three.
So, I'm reading the questions. So for the third question, probably looking at a time series of the filtered anomalies is probably the best way to do that. And I would be very happy to share some of that filter data with you, or share code for calculating it as well. And yes, the NetCDF data is available on an FTP server, and I again would be happy to email that to anyone that would be interested.
So you can move to Roland binary equation. Binary.
Okay.
Yeah. We asked about there are many web types that precursor for enhanced convection in the equator. Is there any web type that can decrease severe weather or climate even in the equator, particularly in Indonesia?
That's a great question, and this is something I'm just starting to look into more, is the impact of these waves specifically on flooding. I haven't looked as much at other types of severe weather. I know Kelvin waves and the MJO certainly are going to have large impacts on those. I think those are the two that have been studied the most. And I think those are the ones that can really have the largest impacts. I'm not as sure about the impacts of some of the other waves. But that's definitely something that I'm very interested in studying. And
So,
okay.
From Dr. Supari, it's possible to add maritime continent in the ocean of the region you're mapping interactive with. Because
Sure.
you know that Indonesia mostly opened your website, the NCICS.
Yeah, I'm very, very proud that you guys are among my top users. And so, yeah, certainly adding a maritime continent option would certainly be easy to do. And yeah, just would have to look at what the best latitude range would be, or longitude range, but yeah.
So it's possible to add the maritime continent?
Yes, I'll work on it.
Oh, great, excellent. The next question from Dr. Gustari. Some of wave type have a very short period, such as Kelvin wave. Question is, what triggers of the atmospheric wave, particularly in the equator region? I think if we know the trigger of the wave, we could probably predict this year.
Yeah, so that's a really, really great question. And I think in some cases, they're triggered by extratropical influences. So, Kelvin waves in particular, I think, tend to be triggered by cutoffs from, very deep frontal zones. But they also can be spawned out of the MJO as well, especially with the Kelvin waves. You'll have a Kelvin wave that'll kind of race off from the leading edge of an MJO. One of the things that makes the Kelvin waves so fascinating to me is that they're essentially, like the question says, they're very short period. They're essentially a synoptic scale feature, but they can last a really long time. Like, you can track an individual Kelvin wave that'll circumnavigate the entire globe over the course of a month. And so, yeah, maybe you don't have perfect idea of when it's going to reach an area or how long it's going to last, but knowing that you probably have an idea that it's coming for some time ahead. And so I think there's definitely a possibility for longer range forecast using that. Maybe like a longer range forecast for a short term event because they do have such a short period.
Okay, the next question is from YouTube participant, Yopi Ilhamsa. Are there any connection between Kelvin wave and heavy rainfall resulting from MGO, and which event to occur the first? Is either Kelvin or MGO?
Yeah, so they are very closely related, and certainly the heaviest rainfall within the MJO tends to be associated with Kelvin waves. In fact, a lot of times you'll see an individual MJO where its enhanced convective envelope is actually like a double, but it'll actually be a double-barreled event where there's like 2 Kelvin waves embedded within the MJO. And those Kelvin waves are where you get the strongest rainfall in association with the MJO. As far as which occurs first, I think it's very event dependent, where a lot of times you'll see a Kelvin wave in the Western Hemisphere when it reaches the Indian Ocean and gets coupled with that greater supply of enhanced moisture and heat. It'll grow upscale into an MJO, but then in the Pacific, you'll see the opposite happen a lot of times, where a full-fledged MJO will kind of shrink into just being a Kelvin wave as it loses some of that energy from the surface.
Okay, the next question from the YouTube, still moving. From Saiful Amri, from Bmkg Tegal. He said it's really heavy and they're really glad to you because he said that very useful website, particularly for weather prediction operational in practice. So the question is, in practice, it's hard to separate these two higher frequency wave type. Using this kind of spectral filtering because they occupy overlapping wave number frequency space, what have right by Frank and Rowdy. So how do you filter the 2 waves, especially the wave number and frequency you are using? Thank you.
Yeah, so I believe on my website, I combine them like Frank and Roundy do into a single filter. It is some other researchers will separate them, where the MRG waves tend to have longer wavelengths and a little bit longer periods as well than the TD type waves. But it's a very kind of arbitrary line between them. And so I find what I prefer to do is use a broader filter and then look at the dynamics or look at the structure to try to figure out whether it's a Kelvin or whether it's a MRG wave or a TD type disturbance. So, if it's only on one side of the equator, then it's probably a TD type disturbance, where if it's got that anti-symmetric pattern, then it's more likely to be an MRG wave. I think that's a more robust way to separate them.
Okay, the next question from Stephen Chahia. Do you think we can build a reliable model that can detect extreme rainfall based on this wave? If so, of those waves you explained, which do you think play a major role and has high predictability? It is possible for us to access the RME indices? If so, could you point us where to?
Yeah, I think this, I think there definitely is a way to build a model to forecast extreme rainfall based on these waves. I think that's what I'm really interested in working on, and I'd be really happy to collaborate with you guys on exactly how to define the extreme rainfall and couple it up with these waves. As far as which of the waves play the biggest role and has the highest predictability, the MJO is going to have the highest predictability. Kelvin waves are probably going to have the highest impact and a little bit less predictability. But I think those are the 2 that I would look the most strongly at. Equatorial Rossby waves would be kind of the third. My guess is that the other kind of higher frequency waves aren't going to have as much of an impact as those ones. And yes, the RMM index, if you want it for the historical values, it's available from the Bureau of Meteorology in Australia. The forecast values, I think they can also be available on my FTP site, but I'd be happy to point you to those.
Okay, thank you. I think the last question for this first presentation, because we still have two presentation. Dr. Carl, my question regarding web identification at first. It is the question from Siswanto. I imagine that you use kind of filtering band method to distinguish the MGO, Kelvin, and Rossby. In doing that, how we can identify its wave propagation? Can you maybe repeat the explanation again in easiest way? Because it's really not easy to us to identifying the three kind of this wave. And for the maritime continent, we know it consists of land, seas, and mountainous region. Do you think that this will be challenge for equatorial wave predictability? It's the question from Siswan.
Okay. Yeah, let me pull up the.
But the propagation.
Yeah, so in terms of like how we identify the filters, so yeah, it is a little bit complicated. And essentially it's identifying different sets of periods and wavelengths. And so, for example, for the Kelvin wave, I've got a Fourier filtering subroutine that identifies wave numbers 1 through 14 in the eastern moving direction, and then periods of like 30, 2.5 to 30 days. And these are routines that I have I did, at the time I did most of my programming in NCAR, command language, NCL. And so I've got a library on a Git repository that has the code for doing this filtering, and I'm happy to share that with anyone that would be interested. I'm starting to learn, I'm transitioning to Python now, but I haven't transitioned this code there yet. But essentially the Fourier filtering is going to, kind of require those underlying Python library or filtering libraries. But kind of in a nutshell, the Kelvin waves are going to be the higher frequency eastward moving signals. The equatorial Rossby waves are kind of the lower frequency westward. And the MJO are these very broad, larger scale signals. Probably not doing a great job of explaining it more clearly, but I'm happy to take a follow-up question on that.
Thank you, Dr. Karsik. Ladies and gentlemen and all participants, we are still introducing actually, but it's a really hot material and topic. So many questions and from the all participants. So we know that in your region, in your country now is 10:35, so it's almost lately night. So I will take a break for 5 minutes. It's enough for you, Dr. Carl?
That sounds great.
Yeah. Dear all participants, we will be break for 5 minutes, and then we will be continue for the next presentation, talking about the method and monitoring the equatorial wave. So please stay tuned and let's take your coffee and break for 5 minutes.
Sounds good.
Thank you. Welcome back, Dr. Clark. Hello everyone. We will be continuing for the second phase. Now I will to confirm to Dr. Clark. We will be continue with the method presentation, or we continue to the hands-on training.
This will be the kind of hands-on, which I apologize. I haven't had a chance to make it as much hands-on as advertised. But.
Okay, so everyone, dear all participants, we will be continuing for the second presentation for Dr. Carl Schick. So please, Dr. Carl, time is yours.
All right. Thank you. Let's see. All right. Yeah, so for this presentation, I'm going to be focusing on kind of giving an overview of some of the key features of my nkix.org/mjo website. And I apologize, I didn't prepare a real interactive hands-on activity, but what I do invite you to do is feel free to click around the website, and I'll be showing some of the key features on there and trying to explain what they mean and how to use it. This website serves hundreds of users every month with MJO and equatorial wave diagnostics, and I'm very humbled that you guys are, again, among my top users for this website. And so I'm very honored to have a chance to talk with you guys today, and am always looking for feedback and ways to tailor the website for users such as yourselves. So my email address is at the bottom of the website, or bottom of the slides. You know, don't hesitate to reach out with ideas or requests. So as I mentioned a little bit earlier, this website uses this unique combination of filtering recent observations along with the model forecast to track the various waves. And then I also have some unique diagnostics looking at the RMM index that get a little bit more into the weeds, into the details of the index than what you might find at other pages. And then if we have time, I'll close with some explanation of some of the model skill that we get from the CFS, and how most of it's actually really just from persistence. So a few of the users that I know of in the US, at least, are I know the National Hurricane Center uses it for their 5-day outlooks for hurricane activity, since Kelvin waves and the MJO play a role in our tropical cyclones here as well. I've worked very closely over the last 10 years with the forecasters at the Climate Prediction Center to help them improve their week 1 and 2 global tropical hazards outlooks. And then the US Air Force has also done some pilot projects looking at weeks 3 and 4, and I think CPC is moving in that direction as well. So these are some of the folks that I've partnered with in the past to help develop this website. Haven't updated it recently, but a few hundred unique users coming to the site every month. And yeah, I've done my best to kind of glean stuff from Google Analytics, and Indonesia's number 6 in the list, so you guys are definitely up there among my users. And I know of, again, some of the US agencies that use it. I've also worked with various private sector entities in the US that use it for primarily in the financial sector for commodities trading. But certainly the thing I'm most proud of is there's a place where you can register to be a user of the website, so that I know who you are and I can send you updates when things are updated or improved. And I'm very proud that over 20 different countries, forecasters from the Met agencies in over 20 countries, including Indonesia, are among the registered users. And certainly academics use it as well somewhat. So we talked a lot about the different modes, and kind of the four that I really focus on the website are low frequency background, BMJO, equatorial Rossby waves, and Kelvin waves. These are the ones that I think have the most potential subseasonal to seasonal forecast potential. I do also include an MRG TD wave. I had some user requests for it, but it's not featured as prominently on the website, but it is there. And we talked about Wheeler and Weichmann's 2001 method, where essentially they take the observations up through today and then pad it with zeros or climatology into the future and then run the filter on that. And the filter is able to take the recent evolution of the waves and extrapolate it into the future somewhat. So on my website, there's a pull down menu for algorithm. And if you select original, that's the Wheeler and Weichmann method. Where if you select the CFS forecasts, that's instead padding with the CFS. This is the default method because it's almost certainly going to be a more skillful type of forecast than what you would get with the extrapolation alone. At least to me, the kind of main feature on the website are the Hofmullers. This is just the easiest way to kind of see where the waves are, and I'll look at a diagram like this, and what I tell people to do is look at the shading and kind of cross your eyes, and that's kind of the easiest way to filter, is just where are the general patterns going. And then you really want to see areas where the shading and the contours are lining up with each other. If there's just one little contour by itself, don't necessarily put as much weight into that. But other times where, for example, here there's a dry MJO here, but it's disconnected from this one and another one at 120 West. Even though the filter isn't connecting those all into one contour, that probably is a single event. And so sometimes, human intuition and interpretation really can help connect some of those dots a lot more cleanly. Similarly, in the wet phase that happened back in August, certainly it was wet over the Indian Ocean and then wet over the Western Pacific with the MJO. Certainly with your eyes, you could trace that into the Western Hemisphere and all the tropical cyclones that we had in the Atlantic and East Pacific. So it's really useful to kind of look at these together. And I think, the other thing is that you can select different latitude bands. Here I'm showing 5 to 15 north. I'll a lot of times toggle between the different latitude bands to try to see which one is showing the strongest signal. That primarily is determined by time of year, but other things can factor in as well. The other thing is, I was talking earlier about OLR is kind of the main way that we track these waves. That's sort of true and sort of not true anymore. Increasingly, I think people are liking to use velocity potential or Chi 200. Velocity potential is really useful because it's a much smoother field. So if I toggle back and forth between these, you can see that it's really showing the same picture. These are both, ways of diagnosing where the vertical motion is. It's just that the velocity potential is a much smoother field. And especially with how complex these waves are and the way they interact with one another, sometimes having that little bit of simplicity of being able to track these waves a little bit more cleanly with the velocity potential can really be valuable. The other thing I've got on here are a variety of maps, and you also have a lot of options for exactly what you want to see. The default is to show OLR for 7 days, and so on the left-hand column, these are the last 4 weeks of observations, and on the right-hand column, these are the next 4 weeks of CFS forecasts. And the default is also to show all of the wave modes, but sometimes that can get very noisy very quickly. And so you can pick just one at a time to get a cleaner picture. So here I'm showing just the MJO contours. And so you get additional contours when you pick that as well. The default only contours the wet regions. By picking an individual mode, you get to see the wet and the dry, with the dry being dashed. And then zoom in on an individual region. We talked earlier about adding a maritime continent region, which is certainly feasible. Because in preparing this talk, I was trying to figure out whether I would use the Eastern Hemisphere or the Pacific one for your region, and I would probably use the Eastern Hemisphere one because it, certainly with these wave modes, you're going to have more things coming from the west than from the east. Both the MJO and the Kelvin waves are going to be coming from your west, and so that's probably more important. As you can see, the filter fields are relatively smooth. So I'm not sure how much you gain by zooming in farther than this, but I can certainly understand how that would be of interest to some users. And then again, velocity potential just makes it a lot smoother. Again, it's essentially the same field, but it's a lot easier to track these things in velocity potential framework. The other thing is that, for some waves, you're going to want different wave periods, different averaging periods. The default is a 7-day average. If you want a really long range forecast, you can do a 10-day average as well. But for something like a Kelvin wave, which is what I'm showing in this slide, the 7-day is too long. It's longer than, it's comparable to the period of the Kelvin wave itself. So that kind of washes itself out. Whereas if you do a 3-day period, the waves pick up a little bit more cleanly than you would with the 7-day period. I also have a bunch of, if you click on the RMM tab at the top of the page, there's another kind of subpage with a variety of diagnostics. And the default is to just show the full RMM index, the real RMM. But there are options with that as well. So one of the things that I find the most useful from this page is the RMM components. And here in the upper left is the full RMM that you'll find on other websites like CPC. But the other 3 panels are the contributions from the individual variables, OLR, U850, and U200. And something you'll see straight off is that OLR tends to be very weak and stay in the center. OLR is a much noisier feature, and it just doesn't contribute as much to the RMM index as we would probably like it to. Typically, U200, the upper level winds in the lower right, that's usually where you're going to get the most power. In fact, you could in a lot of cases, you could just use the U200 and the index would be very similar to the original. Kathy Straub had a great paper, I think it was in 2010 or 2011, that demonstrated how the RMM index is really driven by the circulation features. In the last year, it seems like U850 has really been playing a bigger role. And I don't know if that's because of westerly wind bursts with the ENSO event and then trade surges now with the La Nina and also the wind events associated with the IOD last year. But more often than not, it seems like U850 has been really important in the last year. So the other thing that you'll get out of looking at this is a lot of times when you have a high amplitude RMM event, usually it's going to come from a specific region of U200 or U850. So, you know, with U200, what I'll see a lot of times is there'll be a surge of westerlies from the extratropics in the Eastern Pacific. And that tends to lead to a very higher amplitude RMM in a particular phase. And similarly, like I was just saying, the low-level zonal winds in the Pacific, a lot of times you'll see a westerly wind burst is going to translate into a higher amplitude event as well. And whether or not that's actually really the MJO, and in most cases it's probably not, but maybe there's an MJO component to it as well. The other thing that you can look at on the page is the original versus total. So original, as I mentioned earlier, the Wheeler-Hendon method subtracts a 120-day running mean to get rid of things like ENSO. There have been a few studies, particularly by Phil Klotzbach, that have shown that there's actually value to not doing that. That if you leave the 120-day running mean in, you just take the raw anomalies for the index, then you get kind of a combined MJO plus ENSO signal. So on the left is the original subtracting the 120-day running mean. The right is without doing it. As you can see, they're almost identical. They're just the one on the right shifted down and to the right ever so slightly. And that's essentially because right now the low frequency has had this really enhanced convection over the Indian Ocean, so that's going to pull the index more towards the lower right. The other thing I'll point out while we're looking at this is a lot of times the MJO will make circles that aren't centered on the center. And I think that's still a valid MJO. It just doesn't show up as well in the index. So I would certainly argue that, you know, during this period in August, it was probably active in phase 6 and 7. There was just something, probably the low frequency background, that was counteracting the MJOs so that the observed amplitude wasn't as high as you normally would expect. And kind of to that point, the other thing I have on here are these filtered indices where you can pick just the MJO itself. And so these are U850, OLR, and U200 are each filtered for specifically the MJO using the MJO filter that I use for the Hoffmullers and the maps, and then projecting those filtered anomalies onto the RMM index. And so this will tend to be more centered on the origin than the 120-day running mean can do. And it also gets rid of a lot of those, it gets rid of the interference from things like Kelvin waves and Rossby waves. So you'll have fewer retrogrades and fewer changes in speed. And I think this is probably a more robust reflection of what the MJO is doing at a given time. kind of the drawback is that it's a lot smoother, so it's not going to react as quickly to changes in the MJO state. So I was going to talk about the verifying it, but yeah, I'll go ahead and talk about the verification, and then I'll go back and do some pointing, do some more demonstration. So a paper I did last year was looking at how good the skill was of the various metrics on this website, and the website only has OLR and dynamical variables. In the paper, I looked at rainfall, which is obviously of more interest to a lot of users. And I did that using the NASA TRIM rainfall data set, and used essentially the same method that I use for my website, but I did it for hindcasts from the CFS. So forecast from 1999 to 2010, essentially. And I did verification using a 3-category Heidecke skill score. So this is a skill score that kind of gives you points for when you're in the right category relative to just random chance of saying above, below, or normal at a given time. And so here's an example of what the skill would be if the CFS model was absolutely perfect. And this is useful to look at because the excuse me, one of my children just woke up from bed. I will be back in a few minutes. I'm very sorry.
Okay, sorry, Dr. Clark, please. Iklan dulu Bapak-bapak. Di sana soalnya udah jam 23 lebih 3 menit. Jadi selisihnya 11 jam sama North Carolina. 13 jam malah.
13 jam ya.
Karena biasanya kan selisihnya 12 jam. Ini di kita jam 10.30, di sana tuh sekarang udah
11.30.
23 ya. Jadi 13 jam selisih waktunya, jadi mohon dimaklum. Ini nggak ada yang nanya lagi nih, di chatboxnya masih kosong.
Ya, soalnya sekarang kan praktis, jadi kita merhatiin interaktif webnya.
Bapak-bapak admin, kalau ada pertanyaan dari YouTube silahkan tolong dikopas di kolom chatbox biar tinggal dibaca. Karena sesi kita sampai jam 11.30.
Sorry about that.
Oh, no worry, Dr. Carl.
Thank you, guys. So, yeah, I was saying this is looking at the skill of the forecast of the filter if the CFS was perfect. So this is a way of looking at what is the effect of the filter? Like, how does the filter relate to the actual observed rainfall? Do they line up in the same categories? And this is important because it's essentially this is looking at how well the contours and the shading align with one another, because there's not going to be a perfect correlation between them. And what you'll see here is that the low frequency really has a high correlation with the filtered with the unfiltered categories for the ENSO region, and to a lesser degree for the maritime continent. the MJO has the strongest potential skill over the Indian Ocean, and then to a lesser degree over Indonesia. It's very interesting to me that the MJO has a really hard time producing skill over the Western Pacific, and that's because the ENSO signal is just so strong there. So if you have a really strong El Nino, you're going to have enhanced convection there no matter what. And even the strongest suppressed phase of the MJO isn't going to give you dry anomalies there. It's just going to kind of get you back to neutral, essentially. And then the equatorial Rossby waves, again, are more in the Indian Ocean region. And so you see a similar thing when you look at the forecast for the CFS, where the strongest skill in the CFS model is really in the low frequency. And on the top row here, I'm showing the raw CFS skill. And then the other three rows are the different filter bands. And so you can see that there's actually not that much difference between the top two rows, the unfiltered raw field and that low frequency, the magenta on my website. And that kind of paints an unfortunate picture that the CFS is getting most of its week 3 skill from persistence, essentially. You get a little bit of a boost from the MJO, but not a ton, and really nothing from the equatorial Rossby waves when you get into week 3. If you add the modes together, so you start with the low frequency background and you add an MJO anomalies on top of it, and then eventually add the equatorial Rossby waves to it, the skill gets a little bit better. Because it takes care of that issue of the low frequency just being so strong in one category that the MJO can't really affect it very much. But even here, what you see is actually the strongest skill is just for, at least in the Western Pacific, the strongest skill is just for the low frequency alone. Over the maritime continent region, most of the skill, unfortunately, looks like it's over the ocean regions, which obviously you guys aren't as interested in. But that skill, again, is still really driven by the low frequency persistence, and then maybe to a lesser degree, the MJO's influences. And then kind of another way of looking at this is how many weeks out can you go before the forecast no longer has skill above just throwing dice, essentially. And over the ENSO region, you can go a full 45 days out and still be skillful because the persistence is just that strong. And similarly, over the seas around Indonesia, you can get similar long range skill, but over the land areas, it's a little bit more limited. So the other thing I did was I averaged the skill over individual regions and compared it. And so here the dashed lines are for the entire tropical strip, and the solid lines are specifically for the maritime continent. And the overall skill of the unfiltered CFS is actually a little bit better over the maritime continent than the tropics at large. And that's primarily coming from the MJO being quite a bit more skillful in the actually, both the MJO and the low frequency are both much more skillful in the maritime continent than the tropics at large. But they kind of converge to meet one another when you get out to about 3 weeks, about 20 days or so. At that point, really the weather in the model is not really helping you anymore. at that point beyond just persistence. Another thing I took a look at was how does the addition of the MJO impact your skill for different regions and periods and MJO phases. And so focusing on the maritime continent, red dots are places where the MJO is improving your skill over just using persistence by itself. Blue dots are where you'd actually be better off if you were using the low frequency anomalies by themselves. And probably not too surprisingly, the biggest benefit is in the springtime and to a lesser degree in the winter time. And especially in phases like 3 and 4, I would say. And that probably makes some sense that if the MJO is active just to your west, the model is going to do a pretty good job of propagating that signal eastward for the next week or two. Where if the MJO has already gone past you, it's going to have a hard, the model is going to have a hard time propagating that signal back around again. So here are kind of the key points again that, the website has a lot of users. I try to be very responsive to user feedback. It uses this combination of filtering both observations and forecasts. And the RMM diagnostics kind of give additional insight into what's going on with the MJO index. But unfortunately, most of the models really get most of their skill, at least in terms of rainfall, from just these low frequency persistent signals, and to a lesser degree, the MJO. So what I tell the forecasters at CPC all the time when I do our weekly calls is the first thing they should do when they look at my website is look at the low frequency signals, because those are going to be very high skill. If it's been convecting over the Indian Ocean for the last 3 weeks, it's probably going to continue there. So use those low frequency signals first, then use the MJO. That's going to be your next highest skill. Equatorial Rossby waves and Kelvin waves are kind of farther down the list. So now I'm happy to either do Q&A or do a little bit of interactive clicking on the website, but it'd be fairly similar to what I showed already. So I'm open to either.
Great, thank you, Dr. Carl. Ladies and gentlemen, this is for the last session for this class or this presentation. We know that it's a little bit midnight for Dr. Carl. I'm really sorry.
That's fine.
Midnight. But we still have 16 minutes for discussion, and I will be read for you the question from Muhar Shah Robi. For your information, besides using the substantial model from CFS, Bmkg also used the ECMWF model. So in your opinion, which is better between these two models to be used operationally for the MJO prediction? Have you experienced with that?
Okay, just 1 second. Okay. Yes. ECMWF is definitely the best of the models out there for both for MJO and for the equatorial waves. It still has biases, but CFS is not going to be as skillful as ECMWF. So I was one of my dreams for a while has been to replicate my website using ECMWF data, but it's not freely available to me, being an academic and not being in a weather service like you guys. So.
Yeah, it's not free with ECMWF.
Yeah.
So for Dr. Ansari, can you teach us how to create each atmospheric wave contour overshaded OLR anomaly map? Is it using different data or only using OLR anomaly data? It would be great if you can explain us step by step to produce this map. It could be more class with you.
Yeah. Trying to think the best way to do that.
Yeah.
Let's see. So essentially, what I do is I have three different subroutines that I run that goes between these three diagrams. And so, the initial is the raw OLR, and then I have a routine that subtracts out the daily climatology to give the anomalies, and then a third routine that does the filtering. And at least they're relatively simple function calls. And I'm certainly happy to share the code offline with you guys. That's probably the easiest way to handle it. But yes, the contours, the contours always match up with the variable underneath. So in this case, both the shading and the contours are both using OLR exclusively. There's no other variables being used. Let me show one caveat to that. So one thing I will say on the website, one of the options, so normally when you select it, it's going to be the CFS forecast. So it's going to be observed OLR and CFS forecasts OLR, or similarly, if you did zonal wind, it's going to be observed and forecast. And then the contours are the same variable. The one exception is I did add this CFS with SSTs, which appears to have been broken, but typically it works where there'll be observed SSTs. The contours in this case are still going to be the U200 filtered variable, but the shading is now SST instead to help you see how the waves are interacting with the ocean. I find this is useful, especially in the Pacific, for looking at how the waves interact with the ENSO evolution. Let's see.
Okay, thank you for the demos for the website. And the question from me actually, are the climatology map for this equatorial wave like MGO, Kelvin, or Rossby, when they will be peak occur or active, and when they will be little bit not active? And the second question is about the teleconnection between all this equatorial wave with the IOD. It's really influence about the climate probability in maritime continent, and also with the ENSO. It will be make it stronger or supporting each other, or it will be weaker, one of them. Thank you.
Yeah, so probably I think Paul Roundy 2004, I think, had a good paper that showed showed maps of when each of these waves, that when their variance was the largest and strongest for different times of the year. That's probably the best place to look. I think Coladas et al. 2009 was also a good reference for that. They tend to follow in most regions, they tend to follow the seasonal cycle of the ITCZ to a large extent. And yeah, the teleconnections between the waves and the IOD and the ENSO, I don't know as much about the IOD. I'm sure after last year, there'll be some good studies into that. I know for ENSO, there's been a lot of interest in MJO as a source of westerly wind bursts for forcing the downwelling Kelvin waves, the oceanic Kelvin waves. I imagine, I strongly suspect other waves could have an impact as well, but the duration isn't going to be as long as what you get with the MJO. There are also impacts the other way as well, where some of the MJO tends to be more active when you're transitioning from one page to another, from one phase to another, versus when you're in a strong El Nino or La Nina. The events aren't going to be as strong. But yeah, I think there's more room to look at how the climatology of the different waves changes with the phase of both IOD and ENSO.
Okay, thank you. The last question may be from NTB. I will try to plot and the OLR map in CICS, but it has been more 10 minutes away. The figure still not appear. Does it normal? And I doesn't know the meaning of select day. Is that number day?
Something is broken on the website right now. I apologize that, of course, these things happen right when there's a demonstration. But what I can do is show you, so the few things I can show you on the website. Forgot I wasn't sharing. So yeah, it's not loading for me either right now. For OLR, I guess some variables are loading and other ones aren't. And they haven't been updated in a few days for some of the variables. But a couple of things I can show you. One is that I also have a few diagnostics that are focused more specifically on SSTs for different regions as well. These aren't impacted by the atmospheric equatorial waves at all, but these are similar diagnostics where it's showing the CFS forecasts alongside recent evolution of the waves. And of course, they're not working. But the other feature on here is this archive that I use from time to time, where you can go back all the way back to the dynamo period in 2011 and 2012 and look at these maps. I've saved them every day for the last month, but also I think once a week, going back in time. So we can go back in time to September 2nd when the website was working. And then you can see the OLR maps and zoom in on a particular region of interest, or pick the different waves that you're interested in as well. MRG-TD is another one where you're going to want to select a shorter time frame than 7 days, for example. And then let's see if the SSTs, yeah, these ones will work. So yeah, you can see if you select the SST patterns, you can look at what the OISST was for the last couple of weeks, and then what the CFS forecast is for the next few weeks, which can also be useful. And then I can also show you on here the RMM page, which will look a little different in the live version. But there's a summary chart where you can look at the original Wheeler-Hendon RMM, the total without subtracting out the MJO, or without subtracting out the 120-day mean. There's also the MJO filtered that I talked about. Sum of modes is similar to what we were looking at in the verification statistics, where it's low frequency plus MJO plus Kelvin plus ER. And so it's kind of somewhere between the original and the MJO. So it's got some of the waves in there, but not all the other noise. And then the low frequency is useful to see, where would essentially persistence, where would the long-term signal put you in the phase diagram? And so, right now we would be kind of in phase 3 because of that very strong Indian Ocean signal right now. And then you can click, for each of those different options we just showed, you can look at the components by variable. So frequently I'll look at the MJO filtered components by variable to see, which ones are contributing to the amplitude at a given time, and being able to see it in a smoother framework like this. So with that, I'll see if there were any other.
Great, excellent. I think it's really very interesting class for today and for tonight, actually, for you. And may I share your email, Dr. Sharp?
Yes, please do, and I would be very happy to continue talking with you guys afterwards.
So everyone, for your more question or correspondence, you can send an email to Carl/Sek and at ncsu.edu. So maybe one of our participants will be who will be continue study to North Carolina University. And for your information, one of the Bmkg staff also still doing for his PhD with the Fulbright Foundation from US. He is Albert Nahas. He is studying about the atmospheric with the climate change issue or something in the North Carolina State University. Maybe this is the second or the third year for him. So for all participants, we are really happy and very interesting today, and it's really good opportunity for us to get the material or presentation for the expert, for the Dr. Carl Sek. Once again, from the committee, we will say that very appreciate for you, and thank you very much for your teach us. And I think it's not enough for us to get only in this day presentation or this class. So I hope another chance for us to get the lecture from you. Thank you very much, Dr. Sharp.
Thank you.
Also, our director attend here, Dr. Dodo. You have the remark this class. Could you please, Dr. Dodo, could you please give a remark? Admin, please unmute Dr. Dodo. Could you give a class remark for this class, climate class, for our director to give?
Yeah, already.
Okay, thank you, Pak Aldi, for leading this class, and of course, thanks to Dr. Shark for your very useful materials for us. Yeah, as I mentioned, here we still have about 152 participants attending your class, and this mainly our young scientists for all our office in the region. So yeah, thank you, and hope we can use your tool for our analysis as well as for prediction of our climate in Indonesia. So again, thank you for your time. As I mentioned, this is not so convenience for you in the US. Now already midnight, so I think it's very difficult. But yeah, but it is very nice to have this class. I think we stop now, and thank you for all participants for your active discussion and questions. Please continue as Pak Aldi share Dr. Shrek emails. Thank you, and please Pak Aldi continue.
Thank you, Dr. Dodo, for the closing remark. Ladies and gentlemen, we will be close shortly, but I want to please for every participant to turn on your video, so we'll be take a photo session for our documentation. So the admin will be, or the host will be take it to screenshot.